Okay, in this presentation, we'll be looking at exponential equations, logarithm, and compound interest. All right, so first, our objective is to apply the understanding of using logarithms when solving exponential equations to compound interest problems. So first thing, let's just determine what is compound interest. Compound interest is the addition of interest to the principal sum of a loan or deposit, or in other words, interest on interest. It is the result of reinvesting interest rather than paying it out, so that interest in the next period is then earned on the principal sum plus previous accumulated interest. That's a whole lot. So let's kind of break this up. The best way to explain this, I think, is to compare it to simple interest. So we're going to look at simple interest versus compound interest. In simple interest, let's imagine we had, say, $10,000 and we had it invested at a 10% APR. APR stands for annual percentage rate. We're going to do this for 4 years. So in simple interest, in the first year, we had our $10,000. We'll multiply by 0.1, which is the 10%. So 10% of 10,000 is 1,000. So that shows that we're earning $1,000 in the first year. In the second year, again for simple interest, we do the exact same thing. Take the original $10,000, multiply by 10%, get another 1,000. Year 3, same thing. And year 4, exact same thing. Everything is very simple in simple interest. So the total we have will be a combination of the 10,000 we started with plus the 4,000 interest, giving us a grand total of $14,000. This is an example of simple interest. There's actually a formula for simple interest. Interest is equal to principal times the rate times the time. So if we took 10,000 multiplied by 0.1 multiplied by 4, we would get $4,000 to give us our interest. Let's look at it at compound interest. Compound interest is a little different. In our first year, we'll still take the $10,000 multiplied by 10%, still get $1,000. So at the end of the year, we have the 10,000 we started with plus the 1,000 we just earned in our interest to give us a grand total of $11,000. What will happen in compound interest, we take this 11,000, and when it's time to do our interest, we'll take the 11,000 multiplied by the 10% to give us 1,100. This is what that statement in the earlier slide said, interest on interest. So we gain an additional $100 if we compare it to simple interest. So we take this $1,100 we have, add it to the 11,000 at the end of year 1, and now at the end of year 2, we've got $12,100. So in year 3, we pick up with the 12,100 multiplied by the 10%, give us an interest of 1210. Take that 1210, add it to the 12,100 we already have. So at the end of the third year, we now have $13,310. As opposed to simple interest, we would have only had $13,000. We'll continue to do this in the fourth year. Take the 13,310, multiply by 10%. We now get $1,331 in interest in our fourth year. Add that to the 13,310 we already had to give us a grand total. So our total here is 14,641. Just like over here, there's a formula to help you find the interest for simple interest. We'll look at a formula for using compound interest. This is the formula. A of t is equal to P times 1 plus R over N to the NT. It's a lot. So we'll first look at this a little closer. So here's our formula. A of t, so we'll go through each part. A of t represents the amount that is earned at the end of a stated period. So the A is amount, T is the time. P stands for principal. Principal essentially tells you the amount that you started with. It may not be a dollar amount. It could be just a beginning number. Next is R. R represents the rate. Now the rate will be written as a decimal when we put it into the formula. It'll be given to you as a percentage. N represents the number of times interest is compounded annually. We'll talk a little bit more about this shortly. And T represents time in years. That's critical to understand. Whatever number we substitute for T, that number represents the amount of years. So there's two things that we need to kind of look at a little closer. In this formula here, we'll look closer at rate and also N, number of times interest is compounded. Because once you're able to interpret those two, things go much easier. So rate, you'll be given a rate like 7%. But percent actually means divided by 100. So 7% literally means 7 divided by 100 into the calculator, 0.07. Different one, 12.9%. Again, that means 12.9 divided by 100, 1.129. One more, 0.027% means 0.027 divided by 100. We get 0.00027. If we look back, it looks as if all we're doing is moving that decimal 2 places to the left. The only problem with this is that sometimes we don't get decimals. So if we had 3/8%, 3/8% literally means 3/8 divided by 100. But 3/8 by itself actually means 3 divided by 8. So I could type this directly into the calculator. Let's see what it says. So I could do this several different ways. I could do 3 divided by 8 divided by 100. There's my decimal. Or I could have done, say, 3/8. There's 3/8 divided by 100. Convert that. There's my decimal. Or actually, this calculator has the capacity to convert percentage to decimals. Right above the 8, right there is the percent. So I could have typed in 3/8, moved it over, second percent. Converts it to a decimal. So you've got multiple ways with this calculator. So that's our 0.0375. Last one, 6 2/5%. Again, that means, so if I just looked at this part, 2/5, 2 divided by 5, 0.4. So I really got 6.4 divided by 100. When I divide it by 100, 0.064. Again, on the calculator has mixed numbers right there, that U and D. So if I hit that, I'm able to put this problem right into the calculator. 6 2/5%, second percent. There's my decimal. So the calculator can do it for you if you know where to go. Number of times interest compounded. It's pretty straightforward, but let's look at a couple. Let's say if my interest was compounded semi-annually, that means twice a year, n equals 2. Twice a year is when I would actually receive interest. So instead of at the end of the year, this says once 6 months has passed, you'll get some interest. At the end of the next 6 months, you'll get some more interest. I could compound it monthly. That means every month I get a little bit of interest. That means n would equal to 12. Weekly, n equals 52. Daily, n equals 365. Quarterly, 4 times a year, n equals 4. So let's look at a few problems. Determine the final amount of a $200 investment after 5 years, 3% interest compounded monthly. So we'll start with our formula. So as we go through all the components, we've got P is 200. That's our principal. The rate is 0.03 because 3% interest. Again, we converted the percent to a decimal. We have our N is 12 because they said it was compounded monthly. And T is 5 because it says 5 years. So we simply just substitute everything into the equation. I'll solve this step by step. First thing I did what was inside here. 0.03 divided by 12, 0.0025. Now I'm going to add that together, 1.0025. So now I can type this straight into the calculator. Now I actually could have typed the entire problem in. So I'll start with this. 200 times that 1.0025 raised to that, our caret raised to the 60. 232 point, we get this decimal number here. Now what we're looking at is the final amount. So this amount is money. So it's being rounded to look like dollars and cents. So it looks like we'll eventually have 32 cents here. So $232, 32 cents. So it's really, really straightforward. Determine the final amount, $1,200 investment after 6 months, 2.38% interest. There's our formula. We've got the principal, right there is $1,200. The rate, 0.02375. So again, I showed you earlier how we just put this right into the calculator. N, compounded daily, so 365. And T, 6 months, 0.5. Again, time has to be in years. 6 months, half a year. So we simply just substitute it straight into the calculator. Again, I can work out certain parts of it. If I divide this, I get that. If I multiply this, I get that. And again, all of this could have been typed straight into the calculator. So what I'm going to do this time and to demonstrate, type in the original problem in. That original one was 1,200, let's clear this, 1,200 times 1 plus, that's our fraction, 0.02375 over 365. Move my cursor over, close the parentheses, there's the caret, raise it to 365 times 0.5. Enter. That's our answer. $1,214.33. 1,214, this is what the calculator had. So my answer is 1214.33. So again, these steps that I show here is just overkill. You could have just typed this straight into the calculator. Alright, that's what I showed earlier. Approximately how long would it take a $500 investment to grow $700 in an account? So, same formula. The principal is $500. We have the rate. The rate is 7%. The number of times compounded, there it is, quarterly. And we have now A of T. So this is the amount at the end. They told us we're going to end with $700. So in this case, when we substitute everything in, what we're left with now is actually an algebraic equation. We have to solve for T. So we'll be performing inverse operation. So we'll first divide both sides by 500. And so when I divide it by 500, 1.4 on this side, 500's cancel. Next, I'll go ahead and simplify by combining this. So 1 plus 0.07 over 4. Calculator let us know this is our answer. Now, if we're trying to get T by itself, it's now time to get rid of the number furthest from the unknown, SADMEP. So we need to get rid of this base. And from previous lesson, the base is not a 10 or an E. So what we're going to do is log on both sides and then apply the property. So this is what we're left with. There's the 4T in front. Now to get the T by itself, we divide both sides by that log 1.0175. Notice I'm not doing any math yet, just keeping it all in its exact form. Divide both sides by 4. Type this straight into the calculator. When I type this into the calculator, we get, so fraction, log 1.4, log 1.0175 all over 4. There's our answer. And the time is going to be in years, so that's about 5.